So if we face this question, what is x raised to a complex fraction n over m, we find it's simpler than we feared. So what is 10 to the 4/5 power? Well, it's the combination of the two things that we're now used to. It's 10 raised to the 4th power, and then that number reduced to its 5th root. So that's a compound complex mathematical operation, but conceptually, it's not difficult. You work out those answers, and that's the answer to what that whole figure, 10 to the 4/5 power, means. Now, so we can work that out. What is 10 to the 4th power? It's 10,000. And what is the 5th root of 10,000? Here you need a calculator. And it produces the number approximately 6.31, because if you take 6.31 and multiply it by itself 5 times, you get to 10,000. And here again, we can visit our logarithmic scale just to try to get the concept straight in our mind. And look at the scale between 1 and 10. There's a certain distance. Let's suppose you went 4/5 of that distance up from 1 toward 10 and stopped 1/5 of the way down from 10 toward 1. So you're up 4/5 of that space between 1 and 10, and you trace across to the numbers marked there. About what number do you expect to find at that precise point? To think about it backwards, if you look through the marked numbers and you find the spot where you guess 6.31 is, and you trace over to the vertical line between 10 and 1, how far along are you between 1 and 10? What percent or what portion have you traveled up from 1 and down from 10? One thing that will help you out, it doesn't matter what order you take this fraction. I did it first by raising the number to a power. That I could see easily. To take 10 to the 4th power that's a simple question. But if it helps you to do the root first and then raise the root to the power, you get back to the same answer, and that will sometimes help you solve problems or get a clear sense of what number you're dealing with without having to use your calculator. Mostly you will deal with approximation, and that's one thing that makes people reluctant to deal with these concepts, make them seem strange and gnarly, and people doubt their ability to think about them. But you have that ability if you use your normal brain. And there are certain easy cases, and it's useful to emphasize those for teaching purposes. What is 8 to the 2/3 power? Well, what would it mean? It's either 8 squared and the cube root of 8 squared, or it would be the cube root of 8, and then that number multiplied by itself, that number squared. So that's not a difficult question. We know that 8 is a cube number. The cube root of 8 is 2, because 2 times 2 times 2 is equal to 8. And if we square that, then we get 4. So the answer to the question, what is the 8 raised to the 2/3 power, is 4. Another simplified one, what is 10 to the 6/2 power? Now, you look at that fraction and you probably have already reduced it to lowest terms. We know that's the same as the number 3. And so this sum that this figure that we calculate will have to be equal to 10 to the power of 3. It wouldn't be right to make our uses of the symbols inconsistent. So if any fraction 6/2 means 3, then a fraction in an exponent must also mean that. But it's a useful illustration to work it out step by step without reducing first. What would 10 raised to the 6th power and then reduce to its square root b. Well, we know that 10 to the 6th is 1,000,000, and we know that 1,000,000 is a square number because 1,000,000 is 1,000,000. So if we calculate 10 to the 6th half power, we get 1,000, and that's the answer we knew was due all along.